Hi, today we're going to do 7.2 similar polygons. We're on page 463 in the textbook. Most of these examples are straight from the textbook, so if you want to go through, you want to look at those examples while I'm going through this. Or if you get confused from me, you can always go back and look in the textbook. Just go through the sections and each example. The majority of them are the same. And so the textbook will explain it to you probably in a different way than I'm explaining it. Okay, so similar figures of the same shape, but not necessarily the same size. So down here we have two similar figures. They have the same shape, but they are not the same size. One is larger than the other. Two polygons are similar polygons if corresponding angles are congruent and if the corresponding sides are proportional. So we could assume that these two polygons are similar. If you look, the angles are congruent and the sides look like they would be proportional, but we wouldn't be able to tell unless we're given a number for each side, which we'll get to here in a minute. So the first example, what are the pairs of congruent angles? So this is when it asks you for a similarity statement. It wants you to tell what are the pairs of congruent angles. So remember when we're given this, some of us can't look at these two triangles and figure out which side goes where. But if it gives you this sentence here, and remember how I had said you can put it as M and P, and it's telling you it is congruent to SRT. So the two letters that are on top of each other are the congruent angles. So the similarity statement would be angle M is congruent to angle S, angle N is congruent to angle R, and angle P is congruent to angle T. So that is your similarity statement for the pairs of congruent angles. B, what is the extended proportion for the ratios of the lengths of the corresponding sides? So the extended proportion means that you want to write fractions. And they should all end up equaling each other. So the first proportion that I would say that I'm going to write is going to be MN over SR, because those sides are congruent to each other. The next one would be NP over RT, and the last one, PM over TS. So here's my extended proportion. All these sides are proportional. The top should all consist of the same triangle, and the bottom should all consist of the same triangle. Okay, so let's go ahead and do another one. Example 2, hang on. Example 2 of the polygons similar. If they are, write a similarity statement and give the scale factor. So what does that mean? The first way that we can say, are they similar, is the first thing said was that the angles are all congruent. So if I look here, I have all the angles matched, congruent marks. So I know that's the first part. The second part are all the sides proportional. So we have to write the extended proportion. So remember, that means that I would say MJ over WT equals, and then I would say JK over TU equals KL over UV, and then LM over VW, and then and that's it. I would count, I have 4 sides, so I should have 4 fractions. So that's the first part of it. Now, are they similar? So now what I have to do is I have to go ahead and plug in numbers. So MJ equals 6, WT equals 6, JK equals 12, TU equals 6, KL equals 24, UV equals 16, LM is 24, VW is 14. So all I've done here is just write the ratios. Like we learned in 7.1, I'm just writing the ratios. And then what I want to do is go ahead and reduce these ratios. 6 over 6 would be 1 over 1. Well, we could just write, you could really just reduce it. So I end up with 1 equals 12 divided by 6 is 2. I really don't have to go on because when they're similar, these should all be proportional, so they should all reduce the same number. So does 1 equal 2? No. I could go ahead and continue to reduce. 24 divided by 16, just so that you can kind of see, is 1.5. And 24 divided by 14 is 1.7. So these do not equal each other, so these are not similar. Okay, so they are not similar. So we want to do the same thing for the next one, for these two triangles here. I want to go ahead and look at the angles. I have congruent marks, so I know that's first, yes. The second thing is I need to go ahead and write my extended proportion of the ratios. This one's a little bit more difficult for some because when you're writing it, you have to, they're flipped around, so you have to kind of figure out where am I going to start. If I start at A to B, I'm going to go ahead and write AB over. I want to go ahead and find the angle that is congruent to A, which is D, and then find the angle that is congruent to angle B, which is E. So I'm going this direction. Equals, and then I'm going to go ahead and go from B to C, and so that would be E to F. And the last one is going to be C to A. So CA, then I'm going from F to D, so FD. So here's my extended proportion, and now I need to go ahead and plug in all the numbers. So AB equals 12, DE equals 15, BC equals 16, EF equals 20, and CA equals 8, and FD equals 10. So if I were to reduce these fractions just to decimal, just to see what it is, 12 divided by 15 equals 0.8. 16 divided by 20 equals 0.8. Oops, supposed to be an 8. And 8 divided by 10 is 0.8. So do they all equal each other? Yes. So are they similar? Yes. So the next thing I want you to write is a similarity statement. And remember, the similarity statement is the angles. So I'm going to go ahead and write angle A is congruent to angle C, angle B is congruent to angle E, and angle C is congruent to angle F. And then give the scale factor. The scale factor is the ratio. And so what I want to do is go ahead and take the fraction. I can take any of the fractions, and I'm just going to go ahead and reduce it. So 12 over 15, what number divides both? Would be 3. 12 divided by 3 is 4. 15 divided by 3 is 5. So the scale factor is 4 to 5, or 4 over 5. Okay. And again, this is in the textbook, page 465, these two examples. So if you are confused, if you need to go look at a different way of seeing this, go ahead and look on that page. Okay, so example 3, it says ABCD is similar to EFGD. What are the values of x and y? So we're trying to find x and y. So what I'm going to go ahead and do is, if they're similar, I know that the proportions are equal. So the first one I'm going to go ahead and try to find would be x. So I have FG over, and so what matches FG would be BC, equals, and then I'm just going to use another set that I have numbers for. So what I'm doing here is saying that if FG over BC, and then I can go ahead and pick, I don't know, let's go ahead and pick AD over ED. I'm going to black it out. And so remember that you want to go ahead and use the same figure on top. So if I have FG, I'm going to go ahead and use ED over, and then AD. Oh, did that wrong. They're flipped. So the opposite of what I said you were supposed to do. Or did I? Did I write the same thing? Okay. No, I didn't. That's right. That's right. Okay. So, now I want to go ahead and plug in the numbers that I know. So if I have FG is X and BC is 7.5 equals ED, which is 6, over AD, which is 9. And the reason I know that is here it says 6, and then this symbol here is telling me that the whole entire side equals 9. So now I'm going to use what I learned in 7.2, which is, 7.1, which is cross multiplication. I end up with 9x equals 6 times 7.5. And that becomes 9x equals 45. Divide both sides by 9. And x equals 5. So that is to find x. Now we want to find y. So if I have my y here, I want to go ahead and say EF over AB equals, and then I'm going to use the same one that I had used before, which was ED over AD. Oop. And EF equals y over 5, and then 6 over 9. So cross multiply, I get 9y equals 30. Divide both sides by 9, and y equals 33.3.